all about predicting precipitation. So we're moving on from the common ion effect. We know we can actually predict, given the concentrations of two ion species, we can predict in advance whether they're concentrated enough to cause a precipitate to form, or if they're too dilute and more can actually dissolve before a precipitate will form. And so if the concentrations of ions in solution exceeds a quantity, and that quantity is greater than Ks, or the solubility product, a precipitate will form. Now this quantity we're going to calculate is called the ionic product, given the symbol Q, sometimes Q sub S. And if this value Q is greater than the solubility product constant, we will have a precipitate, and if it's smaller, we know more is able to dissolve. Rarely, if ever, you'll see a problem where it happens to be equal to the Ks. It's always going to be larger or smaller.
Because when it's equal, it's nothing to do.
And the maths for this topic is very easy. The ionic product, you're going to laugh in just a minute at how easy it is to calculate it. Cool. Here's an example of how to calculate the ionic product. It's calculated the exact same way as the solubility product. The thing is, you might be wondering if it's the same. Why isn't it the same as solubility product? It's because the solubility product is only a thing, it's only a constant that exists when the system is at equilibrium, meaning you have a saturated solution of ions, where the solution is saturated, and so you start to have a precipitate forming in it, and that precipitates in equilibrium with the ions in solution. And you have an equal rate of dissolving versus precipitation, right? But the ionic product is a quantity we can calculate at any point in the reaction when we are not sure if equilibrium has been established yet. So we start to dissolve some ions and we're like, are we at equilibrium yet? Well, let's calculate the ionic product and find out. So we form it the same way. So you write your typical expression where Ks or Qs is equal to the concentrations of the ions present. And we're just going to plug in the ion concentrations given in a question. And if that value, Q, is smaller than Ks, we know we still have room to dissolve more ions into solution. So it can be calculated at any concentration of solute, including when the system is not at equilibrium. That's the main difference. It's a very picky thing to say. Okay.
Can you briefly explain what saturation means in this context?
So when the solution or the liquid cannot accept any more ions without a precipitate being formed. If you were to add some more ions, a solid would form because no more can dissolve. So here's an example, a really easy one, because it's the exact same as how you would calculate Ks, right? So in this problem, I have a copper iodide solution, 1-to-1 ratio in terms of copper ions to iodide, right? And so the concentrations of copper and iodide ions are the same as the concentration of the compound. So I plug in 0.005 in for both ion species, and I get my Qs value. Cool. This question is all just testing you, can you calculate ionic product? It's not asking you to compare it to the Ks to predict precipitation. I would have to tell you the Ks in order for you to make that comparison. So right now it's just really easy. Can you calculate Qs the exact same way as Ks? We should know how to do that. Here's another problem. This isn't a 1-to-1 ratio problem. So we have silver chromate, and we know the concentration of silver chromate, but we need to think, how do the concentrations of the ions change compared to that of the ionic compound? So if this is the concentration of the ionic compound, we have to think how many ions are formed. And that's why I always recommend not trying to think about this in your head, because sometimes you'll make a mistake. Actually write out the equilibrium equation. Notice the 2-to-1 ratio of silver ions to the compound. That tells me the concentration of silver is twice that of the compound. And of course, I need to square it as well. So in this case, I do multiply the concentration by 2. I'm not multiplying the silver concentration by 2. I'm multiplying the concentration of silver chromate by 2. And for chromate ions, it's a 1-to-1 ratio. So I plug that number in directly, and I get my QS value. So this should be, you'd be like rolling your eyes, I hope, at this point, because this stuff we've done a couple weeks ago.
Do we have to square it as well, since it's in the
Oh, did
multiplying
I
criteria?
I left a square off.
Okay, cool.
I left a square off. Hey.
How dare you?
Can't believe this.
Should chromate also be 2 lines?
No, because it's 1-to-1.
Yeah, it should be.
2 of the AG2 plus.
You know what?
Oh, yeah.
You passed the
Chromate
test.
Should be a 2
Excellent.
You might need it up the top in
Minus
the
2 minus.
equilibrium equation as well.
Are we happy now?
Always.
Oh, cool.
So why are we multiplying it by 2 again?
Because look at this chemical equation here.
Ratio.
2 silver ions are formed for every 1 unit of silver chromate.
So it's the same for like solubility and that.
Yeah, it is.
It is calculated exactly the same.
That's what solubility means. It's a concentration of the compound that dissolves. That's why we're multiplying it by 2. The concentration of the compound.
It just breaks my brain that they put a whole nother unit in there for something that
Weighted
uses the same
solubility
unit that already
without
exists.
being.
A variable.
So what's the point?
You know, like if it's just concentration.
Okay, this is what we're getting to. The point of the ionic product is that when you compare that number to this known solubility product constant of this compound, that can be looked up on a table or told to you in a question, you will be able to predict, in this instance, is it concentrated enough to form a precipitate, or is it still dilute enough you could dissolve more if you wanted to into that solution? Which, and that's useful for a variety of things. For scholarship students today, we were looking at a cool problem where it asks you at what pH could you precipitate out metals in water that you may not want in your water, right? And these are all precipitates that form hydroxides. That's why it's pH related. Because if you adjust the pH to a certain concentration or a certain pH level, that means you have enough hydroxide ions to cause a metal to precipitate out, to cause precipitation. So in that way, we could use a similar problem like this to predict whether precipitation will happen if we think we have the concentrations of the species just right to remove it from water.
The question in last year's exam was show by calculation whether a precipitate of this compound will form or not, and then they basically just want you to say after you've calculated it, yes, a precipitate will form
And
or no.
yeah, this is the one sort of maths question where you actually have to write a conclusion statement like
Yeah.
you might in maths or something at
And
the
you're
end
like,
of a problem.
therefore, this will happen.
So I want to go over a practice problem here before we put it in practice. This was 2016's excellence question, and I think the next example I have is from last year's exam. So this one says, show by calculation whether a precipitate of silver carbonate will form when a certain volume and concentration of silver nitrate is added to a certain volume and concentration of sodium carbonate. So let's break that down. There's a lot of chemical words happening in this problem. So we've got two solutions we're mixing together, right? We've got silver nitrate, AgNO3, and we've got sodium carbonate, or silver nitrate, yeah, and sodium carbonate, CO3. Cool. These are two ionic compounds. So when they dissolve, we're going to form silver ions, nitrate ions, sodium ions, and carbonate ions. Okay, so this is a precipitation or double displacement reaction where the ions are just going to recombine. The silver, which was originally paired up with the nitrate, might form a compound with the carbonate. Now, sodium nitrate might do the same, but if you know your solubility rules, sodium nitrate is extremely soluble. You're not going to form a precipitate of sodium nitrate. It's extremely soluble. It'll stay as spectator ions in solution. But silver carbonate is the thing that will precipitate out. And that's told to us in the question. It says it could form silver carbonate precipitate. We just need to know if it's concentrated enough to do so. So we're going to calculate that ionic product value and compare it to the Ks that's given to us in the question. So if our QS is greater than that number, a precipitate will form. Cool. So let's do some of the math.
You have to calculate the dilution.
Yeah. Because we are mixing two solutions together, the concentration of silver ions and the concentration of carbonate ions in the combined solution will be more dilute than it was in their separate solutions. Cool. So let's figure that out. So what might the concentration of silver ions be? Let's take the info we've got. So the formula is C times V divided by the total volume of the combined solutions. That will give us a concentration. So the concentration of silver in its separate solution was 0.105. And the volume in liters is 0.020 liters, okay? And we're going to divide by the total volume of the combined solution. So 20 plus 35, 0.055 liters. Cool. And we do that math, and we'll get the diluted concentration of silver in the combined solution. And we repeat that formula with carbonate ions. So C times V once again divided by the same total volume. So, seeing if I, swap markers. Over here we have a concentration of 0.221 and 35 mils over the same total volume of 55. And we will get carbonate concentration as well. And that's the hardest part of these problems, finding the concentrations you need to plug into your QS expression, because QS is going to be equal to silver concentration times carbonate. That's our expression. It's a 1-to-1 ratio, so that expression is pretty short and easy to work with. And once you get that value for QS by plugging these numbers in, all we need to do is say whether or not QS is greater than KS. Is it? That's what we're trying to answer. Now you have a question, Ben.
Yeah. Why are you converting to liters? Don't you not have to?
You don't have to.
Okay,
Yeah.
cool.
Yes, and that's great that you remember that, because liters will cancel. So if you use units of milliliters, milliliters will cancel, and so that's fine as well.
Your concentration for silver will need to be squared.
Yeah, isn't it 2-to-1 ratio?
Oh, you're right.
Yeah.
It is 2-to-1. And look at that. I do have it correct up there. So thanks for pointing that out. Cool. So there's my working on the screen as well. And I did calculate ahead of time that Q is equal to that number, 10 to the negative 4. That's many magnitudes greater than something 10 to the negative 12, right? So right away, bigger number, precipitate will form.
Bigger number, better number.
Bigger number, better number. Okay. One more example. I think I had last year's problem. Yeah. Which one should we do?
The one with the answers.
I like
Let's do this one. Okay. Determine whether a precipitate of zinc hydroxide will form. We have a certain amount of sodium hydroxide, and we have a certain amount of zinc nitrate. So once again, sodium hydroxide. I'm just identifying all of the ions that are present in the solution, because 2 of them are always spectators, 2 will combine to form a precipitate. And we've got zinc nitrate. And I've got a floating 2. Got a floating 2 there. That should be a subscript. Should be like that. And that will dissolve to form zinc 2+ ions and nitrate ions, okay? Now, it's probably identified in the question, what the precipitate will be. It'll be zinc hydroxide, so these 2 ions pairing up to form a precipitate. So zinc hydroxide will be in equilibrium with 1 zinc ion and 2 hydroxide ions, okay? So we know our QS equation looks like this. Hydroxide's concentration needs to be squared. And now we just need to do the messy maths of calculating the diluted concentrations of these 2 species.
And the concentration of hydroxide in the first place.
And that's why I picked this question, because it doesn't state the hydroxide concentration. It just tells you the pH. 13.1. But we're all smart chemists. We can convert a pH into hydroxide.
Of course.
And some of our scholarship students just did it at lunchtime. But the equations are something you'll need, right? The equations you might need are Kw is equal to this equation here. You might need that one to find hydroxide. Because if you have pH, you can convert pH into H3O plus with this equation. And Kw is a constant whose value is 1 times 10 to the negative 14. So those are the two equations you really need. So right now, what we're working on is figuring out the diluted concentrations of zinc and hydroxide. Zinc would be the easiest one because we don't need to figure out its concentration. It's stated to us. But we do need to convert the pH of hydroxide into a concentration. Nelly, is this making sense a bit?
Yes.
I want to see if we can figure it out before we reveal the others.
How do you convert hydroxide?
I want you to try to piece it out with these two equations. So this one contains hydroxide. That's what we're trying to solve for.
Yes.
This is a constant, so we know it, right?
We don't know H0.
But we can find it because
Because
H0
the
plus
pH,
is
can you plug in the
negative.
OH pH into the...
You can plug in the pH of 13.1 into this to
Okay,
find
to find
hydronium.
Okay. Thank you.
What does KW stand for?
It's a dissociation constant for water. Because water is actually in equilibrium at pH 7. It's not a solution of just water molecules. Remember, it contains an equal number of hydronium and hydroxide.
Which is why it conducts electricity.
Yeah, but it's when I say that, a very small percentage of a solution in quote unquote water contains hydroxide and hydronium. Most of it is water molecules, and a small percentage is equal parts hydronium and hydroxide.
How do I know this?
You can just use the ones on the board.
No. Find the hydroxide concentration, you know it. Don't multiply something you know by 2. You're finding OH from the DOH. That's a smart way to do it. Yeah, this way is actually kind of more work.
Yeah.
Yeah, that's the way I did it.
Cool. You guys are on to it.
Because I can't remember the KW.
It's
One
given
by
to
10
you.
to the negative 14 is too much effort for
Yeah. Okay. Too many digits.
The number 10 is just too much to remember.
Yeah.
63 moles will be true.
I don't think I'm very good at rearranging.
Rearranging is my nemesis.
Rearranging, I always muck it up. Because if you want to get something out of the equation, you have to do the opposite of what it's doing. So to get it out of H3O+.
You're solving for hydroxide, right?
Yeah, so I need hydroxide on the left, so I divide it, which
Well,
gives me KW divided by. But
You
then
don't
I
even
end up
need it
with
on the left. You can just flip an equation after you rearrange it. So after you isolate it on one side of the equal sign, you can just flip it over.
But I don't know how to
Well,
isolate
just
it.
move hydronium down. Get rid of hydronium,
So
then
divide
hydroxide's
by
all by itself. Yeah.
Okay, yeah.
So we're making good progress converting pH into hydroxide concentration, and then applying our calculations to figure out the diluted concentration of hydroxide. Remembering what the total volume of the solution is, because we have 30 mils of one, 20 mils of the other.
We need to go.
Wait, I'm so confused.
So that's
Oh, no, that's just
football.
If it was on first copy of the butane, right? So, you know.
Sing it. Yeah. Sing, isn't it?
Where'd you get this number from? Ah, up here.
Something, but
That's 10 to the negative 4. Put a 10 to the negative 14 there.
what's the number now?
I don't know what I was going, but it's here.
But three significant figures, it doesn't matter.
It is 14.
Okay.
So that's right. That's
Yep,
right. I
looks
just
good.
haven't written it correctly. It's a negative.
Alright.
Okay.
Keep it.
So now that is the concentration of hydroxide in its separate solution before you combine it with another solution, right?
Ah, so that's your
It will be
old
more,
dilution
yeah,
rate.
the original one before
Yeah.
you combine it, so it will become more diluted.
So it's in
Remember, you want to do C times D divided by
divided by V
the total volume.
Yeah. Gotcha. I did the other two yesterday, so I think I got this. I hope I got this. It's a good thing the world doesn't rely on me.
Once you find that, the concentration from, you need to put it into this equation.
That's right. Ben, you think you got it?
I think I got it.
Let's have a look. Cool, times 30. Yep. Alright.
Can we have a little bit more time for that?
Yep. And it's greater than 10 to the negative 17. Jeez, yeah, yeah. Just a wee bit bigger.
A little.
Cool.
Wait. Can you check mine?
Yeah.
Wait, it's concentration, what's the number?
That's different QS than what I've seen other students get.
Yeah, it's most times.
I don't know. I don't remember what the answer is. Okay, let's check along the way.
So I got that. So that's
Well, your hydroxide concentration is different from what I've seen too. Where did you figure out that?
that I used those. I got the H2O plus and then divided it.
You haven't written out that work, those steps anywhere? You just kind of did it and wrote the final answer down? Okay, that makes it hard for me to check your work.
But I put the pH
What I do,
down
right, so
to
it's fine.
negative pH, so 30.1. And then I divided, so I did 1 times C to negative 14 divided by the concentration of hydronium. And got that number. And then that's the volume.
Yeah, the 30. Oh, you have too many zeros. 30 mils is 0.03, not 0.003.
Oh, you're right.
That might be one thing. And your zinc concentration? 0.0242, yeah, that's cool. That's right, yeah. So this part's correct. There's a problem in here. I'm guessing it's the concentration of hydroxide. Oh, and I see the mistake right now. You've mixed things up. This is zinc. And you pointed it to hydroxide. I think you plugged them into the wrong thing. Because look at zinc nitrate. There's 20 mils of zinc nitrate. You're given the concentration of zinc nitrate. And yet, it looks like you plug those numbers in here and then you square that. And that's the
Like KS is given.
Oh, no, sorry.
Wait, so they
QS.
okay.
Yes.
7.32.
What if my number is wrong, but I still predict participation?
Alright.
You just swap them around.
What did
That's
you
all
get
right.
for KS?
Redo the calculation.
KS is given to what?
I'm doing QE.
Cool. We're nearing the end here, guys. It looks like most of us are rounding around the corner, getting the final answer.
What did you do the equation for?
Just
I squared the wrong numbers.
Oh, right. Well, you did to 10 to the negative 14.
Which is,
so
yeah,
the-
that's fine, but
Oh,
you,
right,
have
that's-
you done your dilution factor for that?
That's dilution factor rather than that's dilution.
Correct. Precipitation will form, occur.
Will occur or will
I've got
precipitate
that
will
out
form, or you can
by
say precipitation will occur.
extra.
Precipitation. You were right. So was I.
No, I know.
Precipitation.
Did you did right? Did you?
No, you forgot to do
It's
where.
like when you're in those memes about like when you copy your friend's homework but you try to make it slightly different.
Tom Holland, what he would do, he would copy his friend's homework and then hand it in before his friend would, so then the friend would get blamed for.
Oh my god.
Degenerate.
So he didn't have any friends. So he told you. Wait, who was that?
Spider-Man.
Tom Holland.
Yeah.
Yeah, so he doesn't have friends because if you do that, you run out of friends very quickly.
Okay.
That's what I
I'm
figured.
so close. I'm almost there.
Just don't look at the TV.
No, but I can hear what he says.
Just don't watch TV.
Like your ears. This is number.
Yes.
Well done.
Okay. Here we go. Picking it up.
Still much larger.
Is this a 1-to-1 ratio?
I'm.
No.
Nope.
Thank you. Which one's squared?
So.
I didn't get that.
The left one.
The equation's on the board. It's right there. Cool. So, for those who have a final answer and are not ignoring the TV where the answer is up, have a look there. Check that your Q value is the same as mine. Even if you get a larger Q value, bigger than KS, and you're technically right, if your Q value is incorrect because of a calculation error, that could affect your grade. So, did we get 10 to the negative? Well, I shouldn't say, but there's a number here. Compare your answer with that
I've
number.
already got that, but
Yeah.
it's fine.
And look at the concentrations of ions I got along the way. Are these concentrations the same as what you have?
More or less.
More or less.
About right.
Did you round to 1 sig fig throughout the whole problem? That could be why.
I think this should be a challenge.
Yeah, I got it.
Do an entire problem with one sig fig.
Once again, notice I did not multiply the hydroxide concentration by 2 because I'm not talking about solubility. I found the true hydroxide concentration. I plug it in directly. I do need to square it though.
A lot proud of something I found a true
It's good enough. Yeah, rounding. That's fine.
Okay, cool. That's not the answer right now. That's funky.
There we go.
Check your ion concentrations, Annabelle.
Yes,
Start.
Is it okay to work out OH via the
Whatever method you want.
Whatever method you weigh. The way you did was genius in terms of, you know,
Ease.
like I like to joke that lazy chemists try to work really hard to find the easiest way to do a problem. You did the fact that pH plus POH equals 14, right?
Yeah.
And you did that in your head. You didn't even write out that equation, I hope, because 14 minus 13.1 gives us a POH of 0.9.
Yes.
And you said that
Get to the negative 0.9.
the hydroxide concentration is equal to 10 to the negative
Yes,
0.9, and you're done. That's easy.
You got 0.0755 moles per liter. I got 1.26 times 10 to the negative 1.
Interesting.
You need to.
You need to put a concentration of it. Yeah.
You both spoke at once, and so I got
We said the
neither
same
of the
thing.
answers.
But, like 1 second.
Say it again.
Multiply by 30 milliliters and then divided by the new volume.
50.
The
Thir-
actual-
I
times
did
30
that, but
divided by
that's
50.
Not, but that's wrong. The OH concentration's wrong.
Okay, while we move on to problems, I'll come around and help you guys if you still have questions about this one, okay? Now, I hope you notice with these slides, if you're going through them, I skipped a problem, and there's one more after this. This is to provide with you, like here's another one. So I have 4 problems. We only went through 2 as a class. This is to provide you with lots of examples where I go through the steps, okay? So you got 4 problems, each from actual exams. So there's often more on the slides than what I'll go through as class, but we did 2 as a class. If you want to look over more, they're there.
That was last year's exam.
There's a 5th one, my bad. But what I'd like us to do is particularly focus on page 256 to 257. You might want to skip 255 because you understand this stuff. So give it a go.